Okay, last question on the paper. On the whole, this one was done quite well, so well done. An experiment, number of bacteria is growing exponentially. We're given the equation for it. Write down the number of bacteria at the start of the experiment. So at the start of the experiment, t, which is time, is equal to 0. So the equation would look like 25 times 8 to the power of 0. Anything to the power of 0 is 1. So this is the same as saying 25 times 1, which is just 25. So 25 bacteria at the start. Find the number of bacteria after 1 hour. Well, if I change t for 1, that's 25 times 8 to the power of 1. 8 to the power of 1 is just 8. 25 times 8 is 200. Calculate how long it would take for the number of bacteria to exceed 5 million. Give your answer to the nearest hour. So we want this equation, 25 times 8 to the power of t, to be greater than 5 million. So how are you going to do that? Some people used nsolve and changed t for x. You could also think about it graphically. So if we're graphing 25 times 8 to the power of t, it looks something like this. Yeah. And then when does that equal 5 million? Well, I could plot the line just y equals 5 million. What would that look like? Straight line across at 5 million. And I'm looking for that intersection. So analyze graph, find intersection between the two. This came out as 5.87. And then obviously the y coordinate is 5 million. So this means after 5.87 hours, it will be at 5 million. So after that, it's going to be more than 5 million. It says give your answer to the nearest hour. So this would need to go to 6 hours. So final answer, 6 hours. Good job, guys.